This is the last video, I promise. It was cut off. So where we left off was we solved the discriminant of this problem using the quadratic formula. And what I was saying before it was cut off was that under the discriminant, I got negative 1,724, all over negative 32. Since we all know you cannot have a negative number under a square root, you cannot have a negative discriminant, what we're used to putting is no real zeros. But this is a real-life problem, so we have to put it in terms of the problem. So if I can't solve this, no real zeros doesn't really mean anything in the context of this problem. The original question was asking when the ball will be 66 feet above the ground. If I go and try and solve for t, and it's not possible, what that means in terms of the problem is that it will never be 66 feet above the ground. It's not possible. So it will never be 66 feet above the ground. Okay, so that is an option. Part D is asking when the ball will actually hit the ground. So when will the ball hit the ground? We talked about ground. So that means our ending height on the ground would be 0 feet. So what we're going to do now is plug in 0 for h in the equation that we had up here, negative 16t squared plus 50t. So I'd have 0 equals negative 16t squared plus 50t. Now, two options. You can use the quadratic formula, or you can take out the GCF. I'm going to use the GCF because I find that to be a more efficient method. So the GCF of negative 16 and 50 would be a negative 2. The first term is negative, so remember you have to keep a negative with the GCF. And I can also factor a t out of each. So now what's left over, negative 2 times 8 will give me negative 16. And t times t is t squared. And negative 2 times negative 25 will give me positive 50t. So now you set each part equal to 0. Negative 2t equals 0, so t is going to be 0 on that side. And here, if I solve, after setting it equal to 0, I'd get 25 over 8, which as a decimal is about 3.13. Okay, if you round it to the nearest hundredth. Two possible options here. The option we want to use is the 3.13 because it starts off on the ground. So when t is 0, that's our start of our problem. So it starts off on the ground. The football is kicked into the air, and we want to know when it eventually will hit the ground again. Okay, and that will be at after 3.13 seconds. So the ball will hit the ground after 3.13 seconds. Part E, when, remember when means we're looking for time, will the ball reach its maximum height? Okay, so we already did a maximum height problem on this worksheet. So in that case, we're going to use the same equation we started with, negative 16t squared plus 50t. We don't know t, and they didn't tell us a height. So at this point, I would plug in my values into t is equal to the opposite of b over 2a. Well, the opposite of 50 is negative 50, and a is negative 16. So negative 50 over negative 32, when I put that in the calculator, to the nearest 100th, I'd get 1.56. So when will the ball be at its maximum height? it will reach max height after 1.56 seconds. We're finally at the last one, which is just asking, what is the maximum height of the ball? So we're going to take the t value from the problem before, so t is going to be 1.56. We're going to plug that in to find h. So negative 16 times 1.56 squared plus 50 times 1.56. When I plug that in, I got my h to be approximately 39.06 feet. So the maximum height of the ball is 39.06 feet. Please make sure that you copied down everything I have and that you hopefully tried to type these in the calculator as I did to make sure you're good. You will now have another worksheet that you will be receiving. Use your notes from yesterday and this worksheet to complete it. You must turn this worksheet plus the other worksheet in before you leave today. Be good for the SUP.